Welcome to OnRamp, on our way, ending 643. I am Dr. Danielle Morin, and the first module is about basic definitions. We will cover important statistical terms. We will study the difference between variables, measurements, and data, and we will look at level of measurements. Well, what is statistics? There are so many definitions out there. One of them could be the gathering, organizing, summarizing, analyzing, interpreting, and presenting data. All this is true, but is it all? One would say it's the science of number. It is true. It's a branch of mathematics. Definitely. And it is the recording of numerical facts and figures. Yes. And the measurement on characteristics associated with objects included in a sample. All those definitions are true, but statistics is more than this. Statistics is really using this information to make better decisions. The use of number is everywhere. A first example in here, a survey of 2,000 adults reported that 60% thought that an online advertisement of 20 seconds was an acceptable length before seeing free content. When I read a statement like that, I have several questions. The first one, how about a sample of 2,000 adults? First, is the sample a good representation of the entire population? And in fact, what is the population? Are we talking about Canadian population or other populations? The survey that we have results for, can it be expanded, extrapolated, and use that for the population in general? These are very important questions before we put our faith in this survey. Another survey of 1,000 adults showed that 40% of them would be willing to drive 10 to 15 kilometers to save 5 cents on a liter of gas. I have exactly the same question. What about this sample of 1,000 adults? Where were they found? How were people selected? This is something important if I rely on this survey to locate a gas station. Definitely, when we read statements like that, we should be critical. We should be able to identify where information is missing, and most of the time, this is crucial information. Data analytics is statistics, but a lot more. It's basically the changing face of statistics. Of course, we use the statistical method to analyze and explore data, but it is to uncover unforeseen relationships. In the past, we did not have to do that because the data was more simple, but now there's an explosion of data. So we use management science method to develop optimization, and that will impact the organization's strategy, planning, and operations. People expert in the field of analytics are no longer isolated. They are close to the decision-making people. We also need to use information system method to collect and process data of all sizes, because now data sets are incredibly large. As we speak, data is collected. Data collects data on everything in the medical field, in the engineering field, in business. Data is collected. We need to know what kind of data we have and how to use it. There are two different branches of statistics. One of them is the descriptive, where we collect, summarize, present, analyze data. We categorize what we see. The other part, which is extremely important, is the inferential statistics. I use what I found in my sample, and I try to draw conclusion about the larger group. And this is what the sample of the previous two examples were about. We want to know, we would like to use what the results found in the sample to the population in general. And that's why it needs to be very well done. So again, the descriptive, so we use data gathered in a group, we describe and reach conclusion about that group alone. For example, the average in our statistics class. I will not try to use that average in our statistics class to generalize that to all statistics class in the world. The inferential statistics is more powerful. If I have a good sample, the results and the conclusion that I reach in my sample, I will try to use it and extrapolate it to the population if we have a good sample and if the population is well defined. For example, the average liter per 100 kilometer based on 4 cars selected in a parking lot. Can I say something about the entire population? We're not sure about that. So we have to review the sample size, and what we are trying to estimate. Of course, we are dealing with two groups, the population and the sample. So the population, it's everything available, collection of persons, object, item of interest. Maybe I'm looking at all the stores, maybe I'm looking at Quebec populations. The census is the data that I gather on the entire population. So every few years, every 4 years, there are census where the government is trying to collect data on its citizens in order to make decisions about allocation of resources and the like. The sample on the other end is only a portion of the whole, a portion of the population. And we would like this sample, which is smaller than the population, but to be a good representation of the population. So my Quebec adult populations, and this is when I survey the census, I survey all these Quebec adult citizens, and I take a smaller group because it is cheaper, faster than to take the entire population. When we want to study a characteristic, we use what we call a variable, and it takes on different values on different individuals. For example, if I'm looking at the weight of individual, the weight is different from one person to the other. Variables need to be well defined. If I'm talking about the weight of a person, I need to know, is it the weight in the morning, weight at night, and what is my population? And the number that I will get, this is called the measurement, that I will get is called the data. So I record and I store this information. And the statistics, and I will take this data and transform it into useful information. For example, if I have data on 1,000 Quebec residents and I have their weights, well, if you want to know the profile of the population, I cannot give you a sample of 1,000 observation. No, maybe I will give you the average, and that will be a statistics that is calculated from my sample. Again, the weight of 50 kilo, and the average weight would be something more manageable. When I calculate this information from a sample or from the population, so here the parameter is when I calculate it in the population. Most of the time we don't have access to the population. When there are measures about the population, you will learn that we use Greek letters. Mu, this is the Greek letter mu, sigma, and pi. Mu stands for the mean in the population. Sigma, standard deviation in the population, and pi, the proportion. We don't worry about the significance of these parameters yet, because we will see that in different modules. And if I calculate it during using a sample, then I have what we call statistics. The average in my sample will be X bar, my standard deviation S, and P my proportion. We will come back to those very important measures in a future module. Each member of the population may have several characteristics associated with it, right? So if I look at cars in the parking lot, I can look at the color and the speed, the manufacturer, the ranking, the performance, and so on. But those different characteristics, some of them seems to be associated with a number, other colors with some categories. So we will say that they are measured using 4 measures: nominal, ordinal, interval, or ratio. And we will see the difference between them. The type of analysis we can do on these variables will depend on those measures. So we have what we will see. Some will be quantitative data, or numerical is the same thing. So it's a number, maybe the number of children, or the speed limit. Categorical, I cannot do any operation, so it would maybe gender, male, female. It's a category. The hair color, it could be blonde, it could be brown, and I think probably anything in between. When I have cross-sectional data, if the data is collected from several entities at the same time. For example, tonight we will call a sample of 100 people and ask them what they believe the temperature will be tomorrow. Cross-sectional, so we all ask them about the same information. Then we also have time series, and that is quite clear. It's data that is collected over several periods of time. So in summary, we have the variable either categorical or numerical. On the numerical side, or quantitative, it could be discrete or continuous. My categorical, for example, marital status. Political party, you vote for party A, B, or C. The color of your eyes, there are defined categories. This is categorical. In the case of numerical, it could be discrete or continuous. I will call it discrete if I'm counting items. For example, number of children. You have 1, 2, 3, but you cannot have 1.5. The number of defect, it's a defect or it is not. In the case of continuous, it's measurements. Whenever I have to measure something, keep in mind that it can be more and more precise. Like the weight of an individual, 50 kilo. Is it really 50 kilo? But if it maybe it could be 49.99. I can always be more precise, and this is what we will call continuous. So let us try to identify the type of variables that we have. For example, the number of telephone household per household. I can have 1, 2, 3, 0. So this one is numerical, definitely, discrete, and D. The length of the longest distance called made per month. Now, it is numerical, definitely, but the length, I can be always more precise. So in this case, it is numerical continuous. Whether there is a high-speed internet in the house. It is a yes or a no. So if it's yes or no, it's categorical. Amount of time spent shopping at the bookstore. It is numerical because I will have maybe 1 hour, 2 hours, but to be precise, so it will be numerical, continuous, because time is measured, I can always be more and more precise. Academic major is your major finance, marketing, therefore it's a category. Gender is not numerical, so gender is also a category. Computer literacy. Above average, average, or below average. So again, these are categories. Temperature in Celsius. So this is numerical, continuous. I can always be more precise. And the temperature in Kelvin degrees, also numerical, continuous. Just Kelvin degree, to give just information, This is the degrees that are used mainly in physics. So we are familiar with Celsius, Fahrenheit, and Kelvin degrees. Kelvin is the one that we don't really use in business, right? Now, categorical variable can be either nominal or ordinal, and numerical can be interval or ratio scale. The lower scale, the one that doesn't give me too much information, is nominal, male or female. Higher scale, these are the number that we can work with easily. So let's look at those things. Categorical, the nominal scale, it's distinct category and there's no ranking. Gender, hair color. We cannot say that brown hair color are superior to black hair color or the blonde are superior. No, there is no order. Therefore, it's called nominal. In the case of ordinal scale, there's some kind of ranking involved. For example, your level of satisfaction. You're not satisfied, you're neutral, or you're satisfied. So this one, there is a level. So you agree, you strongly agree, or disagree. So there is a level in the support that you give to this information. In the case of numerical, we will have interval scale or ratio scale. The most common is the ratio scale. It could be, it's a measurement. It's the difference, it's ordered. And the difference between measurements is a meaningful quantity. And the measurements have a true zero. Let us see what it means, a true zero. If I say the number of telephone that I have in the house, if I don't have any telephone, it's zero. It is true, it is zero. But if I have the temperature outside is 0 Celsius, what does this zero mean? Is there really zero, no heat whatsoever? No, this is, of course, it's at the point it starts to freeze, but it is not the absence of something. A true zero means when there is an absence of something. This is where we involve the Kelvin temperature degree. Kelvin has a scale that goes very low, and at 0 Kelvin, this is where there is absence of movement in the particles. This is the only true zero temperature. We don't use it. You will never ask somebody, what's the Kelvin temperature today? But in physics, this is one example where we have a true zero. For that reason, the Celsius or Fahrenheit are interval scale. They don't have a true zero. The SAT scores, any results that are standardized, they don't really have a zero score, a true zero. Number of children, it's possible you have no children, it is a zero. So it's a true zero, it's ratio scale. So let us use it in our example here. Number of telephone per household. Again, there is a true zero. This is a ratio. The length of the longest long distance call made in a month. Yeah, maybe you did not make any long distance call. There is a true zero. It's ratio. Whether there is high-speed internet connection in the household. Is it nominal or ordinal? Is there an order? No, there's no order, so it's simply nominal. It's yes or no. Time spent in the bookstore. Is it possible that you don't spend any time at all in the bookstore? So there is a true zero, it's ratio. The academic major. One should not say that one major is superior to the other, whether you choose marketing, finance, or management. So these are simply nominal scales. The gender. No gender is superior, so it is nominal. Computer literacy. Above average, average, below average. In this case, there's some kind of order, so it's categorical, ordinal. Temperature in Celsius degree, we saw that there's no real zero with Celsius, so we say it's interval scale. And the temperature in Kelvin, yes, it does have a true zero, then it's ratio. That ends our first module. At this point, you should reread your notes and try to solve some of the problems that we have put on the Moodle site for review problem. Hope you have enjoyed it. See you in Module 2.